Alright, the speed of a transverse wave in strings. The speed of a transverse wave depends on the following factor: the force which is applied, or what we call tension, and the linear mass density. The linear mass density is known as mu, which is mass per unit length of the string. Use the method of dimensional analysis to determine the expression for the speed of the transverse wave. Dimensionally, you have the speed is v proportional to F, which is the force applied, raised to power x, and the linear mass density mu, which is to power y. That gives v equals to k. You introduce a constant to remove the proportionality sign, F raised to power x, mu raised to power y. Now we know that v is F raised to power x mu raised to power y. If we remove this constant, call this the equation star, where your k is a dimensionless constant, okay? And v now, v is our velocity or speed, which is in meters per seconds, and F is our force. Force is product of mass times acceleration raised to power x multiplied by the mass per unit length. That mu simply means mass over length, or raised to the power of y. So here now you have meter per seconds equals to mass is kilogram times acceleration is meters per second squared, all raised to power x multiplied by mass here is in kilogram again, kilogram, so you have kilogram and meter for length, that is per meter raised to power y. Here now you have meter per seconds equals to, open the bracket here, you have kilogram raised to power x dot meters raised to power x multiplied by seconds raised to power minus 2x, then dot on this other hand also kilogram raised to power y dot meters raised to power minus y, which is minus 1. So this is now m per seconds equals to, collect the like terms together, what you have for kilogram, kilogram raised to power x, kilogram raised to power y, from the law of indices, that is multiplication between them, that means you add the index. So you pick one of the k, kilogram, kg, then you add x plus y dot, then the next one meters, for the meters x, between them x minus y, then dot, pick the next one which is seconds just alone, minus 2 raised to power x, 2x. Now you go ahead for comparison, you compare for when m, what is the value of m on the left hand side, m is to power 1 here, so you have 1 equals to, on the right hand side you have it as x minus y, call this equation 1. Again for kg on this other side, there is no kg, that is 0. On this part you have it as x plus y, call that equation 2. Then for the seconds, on this other side you have seconds to be raised to power minus 1 equals to minus 2x, call this equation 3. Now equation 1, 2, 3 is set. From equation 3 above, it's possible for us to get a value for x, because we have it from equation 3. You have minus 1 equals to minus 2x. So if we divide both sides by minus 2, you are going to have your x to be 1 over 2 settled. Now put the value of x equals to 1 over 2 back to equation 2, and you have a value for y. So from equation 2 now, equation 2, you have 0 equals to x plus y. This is your equation 2. What can we do here? We can make y the subject of formula, so we move x to the other side. So you have minus x equals to y, and x initially is 1 over 2, so you have y to be minus 1 over 2, and you have the two values. Therefore x equals to 1 over 2, y equals to minus 1 over 2. So what do we do next? Put the value of x and y back to the first equation, which is v equals to k f raised to power x dot mu mass per unit length raised to power y. So you have v equals to k f, x is now raised to power 1 over 2 multiplied by mu, which is raised to power minus 1 over 2. So here now you have v equals to k. 1 over 2 mathematically means square root, so you have square root of f multiplied by, this is negative index, so it's going to be 1 over square root of mu mass per unit length. Note, u raised to power minus 1 over 2 is same thing as 1 over u raised to power 1 over 2. So here now you have v equals to k, then you have root f over root mu. So you have finally v, which is the speed of the transverse wave, is now k. Then give them a common root from surd, you have it as f over mu, and this is what we call the equation or the speed of a transverse wave. You use this to solve so many questions under vibrations and wave.